Okay, response video on this, whatever, more of this determinism stuff, randomness, probability, quantum, and more specifically, I guess, radioactive decay. Now we have to talk about that. And it's, Pyro mentioned it again in some old video he posted. Well, he posted a new video talking over an old video, which wasn't a great idea. But anyway, yeah, this argument's been going on for 3 years between us, and we're not getting anywhere. Same old crap back and forth, but whatever. So this guy says some stuff, and it just sets right into the argument. Really, this just illustrates why there's an argument here.
Which is mostly what I did, because we weren't really interested in how much I-125 there was. It was bound to something else that we did want to know how much of what there was, and we could use the molar relationship to determine that. In any case, if you go to the atomic level and you look at the individual atoms of I-125 in your sample, and you pick one to look at, it might go, within seconds of you looking at it, or it could just sit there, and sit there, and sit there, and sit there. And there's absolutely no difference between it and any other one. It's completely random. There is no way to predict if one...
It's not about predicting. It's about what mechanism is operating or functioning at the atomic level. Now, you're basically said in this video, there's no way to tell the difference. You said this like 4 times in the video. They're identical atoms. That's what you said. How do you know they're identical? You can't see them. You know nothing about their individual circumstance, and yet you're saying they're identical. Now, what sense does this? Is that a fair way to describe the circumstance? Is that a fair way to describe the mechanism? It's the same thing with pyro. So let's talk about radioactivity and how it is stored in atoms, because it's sort of, I think of radioactivity sort of like battery, like matter is able to be a battery of sorts, and the battery degrades over time. And that's basically what happens with radioactivity. It has a half-life, it'll degrade. And so let's describe it, let's model it as a physical circumstance and recognize that the physical circumstance will be different in each individual atom. It won't be the same identical physical circumstance. You keep talking as if the atomic structure is so simple that there can be no distinction, that each atom will function exactly the same way, the mechanisms will be in the same exact circumstance, and there cannot be more than 1 variable or 2 variables or 3 variables. There couldn't be such a thing as 1,000 variables or 1,000,000 variables. And so that's why, in some sense, I think the Newtonian concept of the atom with the orbiting electron is a good model. It might not be accurate. I'm not voting for it. I'm just saying it's a model. And so let's go with that. And so let's go with that theoretically. Let's look at it and say, okay, let's suppose that when you make something radioactive, what you do is you tilt the orbits of a couple of things. So now Mars and the Earth are in the same orbit, or they have an intersecting orbit. And it intersects, in 1 in 1,000 rotations, you would expect a collision. So 1 in 1,000 orbits between the planets, you would expect a collision. That's basically radioactivity now. You set up a circumstance where 1 in 1,000 is the probability. It isn't going to be the absolute circumstance for every single atom. It's going to be what the likelihood is, the mean even. So some will collide much sooner because of their circumstantial orbits are set up that way. Some will collide much later because their circumstantial orbits are set up a different way, so that they just miss each other, that first 1,000 probability. And the second 1,000, oh yeah, they missed just the other way. And they keep missing because they have a personal eccentricity, okay, that sets up a different dynamic. And so you have a range of possibilities going from it happening this instant to it happening 5 years from now, let's say, as realistic possibilities. And and everything will fall in that range, and you'll have a medium, an average that'll be somewhere in the middle of that, and probabilistically, and you'd call that a half-life number or whatever it would be. And so there's an it can be explained as a cause and effect mechanics. There is no need for any randomness. The fact that atoms can be affected in incredibly subtle and unique ways, not because they're all the same. This idea that all low-level microphysics, or whatever you want to call it, can have no variability, that there's only a few circumstances, that there's only like 5 parts to the thing, and those 5 parts can only go together in 5 different ways, and that's all there is nonsense. They can have more complex potentials than that. Okay, even though there are very simple systems. So you can have a very simple system where you just have battery A rotating around battery B. Very simple in the obvious sense, but depending upon how far away exactly that battery is from each other, then it becomes there's a full range of possibilities. They have an infinite potential difference from each other. And it's that difference that accounts for this thing you're calling some sort of random phenomenon. No, it is not random. The atoms are not identical in the strict sense of the word. And so your whole foundation, your whole premise is bullshit. And then you sit there and you base a whole argument defeating a whole nother philosophy based on it. You can't see how bogus that is? You didn't defeat determinism. You're just an arrogant little putz to sit there and say you've defeated it because you haven't gone to the trouble to even explore the possibility of a rational, reasonable model that could be constructed that would explain the phenomenon that you can't see. And quit saying you can see things you can't see. Quit saying when you look at as if you have looked at, because you have not looked at. It's just bullshit, bogus nonsense. Okay, enough. I'm not gonna. I don't think there's a huge point in having to go through all this detail. I don't know. I mean, it'd be nice if somebody who really had qualifications did it. I guess that would be nice. Because I'm not. I mean, I know a little about a lot, but I'm not an expert on all of this stuff. And somebody better me should be making the argument. We're stuck with this, I guess.